Hello, welcome back, and check this question here today. It's kind of a puzzle. In a barn there are people and horses inside. In all there are 10 heads and 32 feet. How many horses are inside the barn? How can you solve this? This is the puzzle, and at the end of the lesson we can solve and try to find the answer for this puzzle. Today we will work on Chapter 4, System of Equations, Section 4.3, Systems of Linear Equations and Problem Solving. The objective number 1 is to solve problems modeled by systems of two equations. The step-by-step is this. We have to first understand the problem. During this step, you have to become comfortable with the problem. Some ways of doing this are to read and reread, and another way is to choose two variables to represent the unknowns. You can also draw a picture. You can propose a solution. Just guess a number and propose a solution and check if it's right or wrong. These are ways that you can do, that you can apply to try to understand what the problem is asking. Next, you have to translate the problem into two equations. Number 3, solve the system of equations. And number 4, interpret the results. You have to check if the proposed solution produces true statements, if they are acceptable, and then you can write down, you can state your conclusion. Let's see how it works on an example. One number is 4, this is the question. One number is 4 more than twice the second number. Their total is 25. Find the numbers. So read, reread, understand what the question is asking. We can suppose, it's suggested here, that the second number is 5. Let's say the second number is 5. Then the first number, which is 4 more than twice the second number, will have to be, if the second number is 5, the one number, or the first number, is 4 more than twice the second number. We are guessing. This is a guess. This is just a wild guess to try to understand. Let's check what happens. That means the first number is going to be 4 plus 2 times 5, 10, 14. So one number is 14, second number 5. Their total is 25. So if we add 5 plus 14, needs to be equals to 25. Is this true or false? Definitely is not right, it's false. That means this is wrong. But we're just doing this to understand. See, we're not trying to solve the problem. We're just guessing a number here and checking to understand what the question is asking and thinking how I would solve it. Since we are looking for two numbers, we can let x to be the first one. We can assume variables to the numbers that we don't know. So x can be the first one, y the second one. So we will have one number is 4 more than twice the second number. So you can write here x, one number, is 4 more than twice the second number, right? And their total is 25. That means if we add x plus y, we have 25. Now we have a system with two equations. And let's write the system here. Is x equals 4 plus 2y, and x plus y equals 25. See? We have a system with two equations, and we can solve this system. We can, in the last section, we learned 3 methods to solve the system of 3 equations. We can solve by graphing, we can solve by a substitution method, or we can solve by elimination method. It's up to you. Maybe since we have x equals 4 plus 2y, we can use substitution method, right? We can substitute x here. So x 4 plus 2y, this is x, plus y equals 25. Now you can simplify and apply addition property, multiplication property, and you will have 3y equals 21. Divide both sides by 3. Y equals 7. Okay? If y equals 7, now plug in into the first equation to find x. X equals 4 plus 2y. 4 plus 2 times y, 7. So x equals 2 times 7, 14, plus 4, 18. X equals 18. The solution, the order pair, is going to be 18 and 7. Check into the system of equations, into each one of the equations, if this is the right solution. So plug in for x equals 18 and y equals 7. Plug in into each one of the equations and check if it produces true statements. So this is true. On the second equation, we're going to plug in the values and we'll say, yes, this is true. Then you can state the two numbers are 18 and 7. The two numbers that we're looking for, they are 18 and 7. Another example, Hilton University Drama Club sold 311 tickets for a play. Student tickets cost 50 cents each. Non-student tickets cost $1.50. If the total receipts were $385.50, find how many tickets of each type were sold. Again, understand the problem first. Read, reread. You can suppose, you can just guess. Guess that the number of student tickets was 200. Let's say the number was 200, and then try check what happens. If 200 is the number of student tickets, the non-student will be 311 minus 200. This is non-student, right? Is 111. And if each student ticket costs 50 cents, we can multiply 200 by 50 cents and add the non-student tickets with 150. So 111 times 150. And check the result. If you do the math, you can use a calculator, or you can find out the answer. You're going to find that the result is going to be, let me see here, 266.550. And this is not the right answer. We are looking for 385.50. That means our proposed solution is wrong. But we now understand what you have to solve. Since we are looking for two numbers, we can say S is the number of student tickets, N is the number of non-student tickets. And then you can translate into math equations. The number of student tickets plus the number of non-student tickets is, the total is 311, right? The total receipts were $385.50. So the admission for students is 50 cents times the number of students S plus the admission for non-students is 150 times N, and the total receipts 385.5. Now we solve this system. The system is S plus N equals 311 and 0.5 S plus 1.5 N equals 385.5, right? We can apply addition methods, substitution methods, even graphing, but let's think here. Maybe we could use, I don't know, what do you think about, yes, maybe elimination methods. Maybe elimination. We can multiply this by 2, and we can multiply the first equation by -1. So let's see, after we do the multiplication, we're gonna have 0.5 times 2s, 1.5 times 3n, s plus 3n, and 385.5 is going to be 771, right? 771. And this, the first one, the first equation, negative s minus n equals negative 311. Now add both equations. You can eliminate here s and 3n minus n, 2n. 771 minus 311 is, check it out, 0, 6, and 4. That means divide both sides by 2, n equals 230. So the non-student tickets is 230. You can plug in, substitute into one of these equations, maybe the first one here, to find s, and s is going to be is 311 minus 230, which is equals 81, right? Checking the answers. Substitute into each one of the equations. S equals 81, N equals 230, and try to understand if they are true. They produce true statements. And yes, on the first equation, it produces a true statement. Yes, on the second equation, it produces a true statement. And you can come to the conclusion that the number of student tickets equals 81, and non-student tickets equals 230. You can come to this conclusion, which is going to be the answer to your problem. Another example, and when you get the practice, you can do this thing much faster, and even the check. Sometimes you spend a lot of time on the check, but when you get practice, things get faster and you get confidence. let's check this example here. Terry Watkins can row about 10.6 kilometers in 1 hour downstream and 6.8 kilometers upstream in 1 hour. Find how fast he can row in the still water and find the speed of the current. Try to understand, reread the problem. Let's propose a solution. Let's guess. We are guessing a solution just to understand the problem. You don't need to do this after. If you think you understand what you're supposed to do, what you understand how to translate into math, you don't need to guess a solution. It's only in the case that you are still confused, then maybe, yes, guessing a solution is a way of getting to get a hold, get better knowledge what is being asked. And you know that the basic formula for distance, to calculate the distance is equals to rate times time, right? Or rate times time equals distance. But it doesn't take into consideration the currents, the effect of the water currents. Suppose Terry can row 9 kilometers per hour in still water, and the water current is 2 kilometers per hour. Then we will have the distance in 1 hour is going to be, S times T, upstream or against the current. Let's say first upstream or against the current. You're going to have the speed or the rate equals to 9 minus 2 times 1 hour. And this is going to be 7 kilometers of distance upstream. And downstream, the distance is the speed downstream is the current now is helping. You have to add the current times 1 hour and is 11 kilometers. But this is wrong, right? Have a look. This is going to be wrong because the right numbers are 10.6 and 6.8. So we can say yes, they are kind of close. They are not far from the numbers that we're looking for, but they're wrong. It's not yet the right answer. Let's say the rate of the rower, let's call a variable here, is R. This is the rate or the speed of the rower. And the speed of the current is going to be W. That's rate or speed of water current. Okay? Now we have two variables. Let's try to represent the problem using equations. The rate downstream the current is helping, so the speed is greater, is R plus W. The time downstream is 1 hour, and the distance downstream is 10.6, right? 10.6? 10.6. Now, the rate upstream the current is holding the rower back, is more difficult, is lower, so the current is negative. The time is also the same thing, 1 hour, and the distance upstream 6.8. We have now two equations with two variables. We can represent here a system of linear equations, R plus W times 1 equals 10.6, and R minus W times 1 hour equals 6.8. Check this. We can apply substitution method or elimination or addition method. It's the same thing. But I think this is a case where the elimination or addition method is better, because if we add, we're going to have 2R, and we eliminate the water current, and this is going to be equals to 10.6 times 6.8, 17.4, right? That means R divide 17.4 by 2, and you have 0.7, 8.7. This is the rate of the rower, and is kilometers per hour. We can find now the speed of the water current by plugging in this number into the first or the second equation. Maybe the first one, 8.7 plus what? Plus W equals 10.6. That means W equals what? 10.6 minus 8.7, and it's going to be 1.9, right? 9 kilometers per hour. State your conclusions. After you interpret, you check, see if 8.7, R equals 8.7 and W equals 1.9 is if it's going to produce true statement. If you plug into the original equations, into the system of equations. So yes, true statement, yes, another true statement. That means the rate of rower is, we found 8.7 kilometers per hour, and the rate of current is what? 1.9 kilometers per hour. Those are the conclusions. You can state, you can say that those values are right. Okay? Let's try another example, and we have here a candy bar shop manager mixes M&Ms worth $2 per pound with trail mix worth $1.50 per pound. How many pounds of each should be used to get 50 pounds of a party mix worth $1.80 per pound? It looks like a complicated problem, right? We'll read, reread, try to grasp, to understand. We are going to propose a solution. This is a method, right? You don't need to do this every time, but if you still don't understand, just guess a number. And then we're gonna find if it's right or wrong, but at the end, we will understand better the problem. To find out the cost of any quantity of item, we're going to use this formula here. Price per unit times number of units equals price of all units. Let's guess. Let's suppose the manager decides to mix 20 pounds of M&Ms, right? So 20 pounds of M&Ms. We know that the M&M costs $2 per pound. So we multiply by $2 per pound, the total cost is $40, right? The trail mix, this is the M&Ms. Now the trail mix. If the total mixture is 50, the problem says here the total mixture is 50 pounds, right? So we have 20 pounds plus 30 pounds to have 30 pounds, and the price of the trail is $1.50. So we're gonna have a total price of $45. The mixture we need the mixture with the 50 pounds, and we need the price of the mixture to be 180. Let's check if 40 plus 45 is going to be to this number here. And 50 times 180 is $90. That means, no, we have 40 plus 45, 85. That means this is wrong. This is not going to be 20, and this is not going to be 30. We need to find the right combination. So now we understood the problem. We know one solution that is actually not the solution, is the wrong one, but we can write down an equation. Write down two math equations to find the right solution. Translate into equation. We can say that x is an unknown amount of M&Ms. And y is the unknown amount of trail mix. We need to add x plus y and make what? 50 pounds, right? If you add x and y, the total weight, the total amount is 50 pounds. The price of M&Ms is 2. If you multiply by the amount of M&Ms, x, and add, you know that the price of trail mix is 1.50, and multiply by the amount of M&Ms, y, needs to be equals to what? 1.80 times the total amount of 50 pounds. We have two variables that we don't know, we want to find out. We have two equations. That is a system of linear equations in two variables. So write down here the equations that we have: x plus y equals 50, yes, and 2x plus 1.5 y equals 90, which is 90 is 1.8 times 50. You can use substitution method if it's your favorite. If you can use elimination or addition method if you prefer. I think I like elimination method. I think this is another situation where you can apply elimination method by multiplying each equation by a number. Let's say we multiply the first equation, the whole thing by 2. Multiply by 2, and then we have 2x plus 2y equals 100. And the second equation we can multiply by -1. And then we will have -2x minus 1.5y equals -9. And now add the equations: 2x minus 2x, 0, 2y minus 1.5y, 0.5y, and 100 minus 90 is 10, right? We can find that 0.5y equals 10. That means y equals 10 divided by 0.5, 20. Y is 20. If x plus y is 50, that means x is equals 30. Check, interpret the results, check into each equation, plug into each equation and find if it's true. For the first equation, it's going to be true. The second equation is going to be true as well. And then you can state we need to mix what? 30 pounds of M&Ms with 20 pounds of what? Trail mix. And this is going to be the right answer. Okay, and now we will solve, let's work now on objective number 2, solving problems with costs and revenue. This is kind of a special situation where is a very common application of system of linear equations, and we're going to find several problems that involves cost and revenue. Example here, the company that manufactures boxes recently purchased 2,000 worth of new equipment to make gift boxes to sell to its customers. The cost of producing a package of gift box is $1.5, $1.50, and it is sold for $4. Find the number of packages that must be sold for the company to break even. And there's an interesting concept, important concept that you need to understand here. What means break even? If you don't know, let's understand, let's learn now. The company will include a one-time cost. This one-time cost, I think, is machinery, is equipment, right? So it's just one time. And then $1.50 per package. The revenue will be $4 per package sold. First, let's define a few variables here to work this problem. Let's say we don't know yet X as the number of packages of gift boxes that we will make. So is the number of packages, right? And we need to calculate the cost, so C, as a function of the number of packages. C of X, this is the cost as a function of the number of packages. Function of X. And the revenue, the same thing, the revenue. How much money we will make, revenue, as a function of the number of packages we will make, as a function of X. Let's try to translate now this into math equation. We have to find the revenue as a function of X, and every time we sell a package, we're gonna receive $4, right? So this is the revenue is gonna be $4 for each package, or 4 times X. The cost, and the cost we need to take into account the price that the money that we spend to produce each package, which is 1.50, is times X. But we also have a one-time cost. It's the machinery that we are buying, or the equipment that we are buying to produce the packages, is 2,000. Now we have revenue and we have the costs. Break even, the definition of break even is when you have the revenue equals to the costs. That means if you are in a business, you put some money, then you receive it, all the money that you invested, that you put in the business, you receive it in return. the same amount, so you don't have a loss, you don't have a profit yet, but at least you don't have a loss. You broke even. That is what means break even. And to break even, you need to have revenue equals to cost. That means 4 times x, which is the revenue, equals to cost 1.5 x plus 2,000. Right? Now we can apply additional property of equality and multiplication property and solve this equation to find x. Subtract 1.5x on both sides. And then you will have 2.5x equals 2,000. And divide 2,000 by 2.5. Then you find x equals 800, which is going to be the number of packages that you need to produce to break even. Interpret the result. To see whether the break-even point occurs, you have to plug in the number into the equation and check if the revenue is really equal to the cost. So check this. Yes, 3,200 is the revenue and 3,200 is the cost. They are even. You can state the company must sell 800. The company must sell or produce and sell what? 800 packages. Of the gift boxes to break even. Good, and then we are getting to objective number 3, which is to solve problems modeled by system of 3 equations. And let's go straight to an example here. The measure of the largest angle of a triangle is 90 degrees more than the measure of the smallest angle, and the measure of the remaining angle is 30 degrees more than the measure of the smallest angle. Find the measure of each angle. Well, this is an application in geometry. Read and reread the problem. We are going to propose a solution, and I think when we have something like that, it's interesting to draw a picture as well. Remember one of the things? Draw a picture. We can draw like a triangle, any triangle, and we can say S is the measure of the smallest angle. Let's say this one is the smallest. M, the measure of the middle angle. Let's say M is the middle angle, and L the measure of the largest angle. And this is the largest angle. We have 3 variables, 3 angles that we don't know, S, M, and L, but we know as a property of the triangles is that the sum of all the inner angles total 180 degrees. So if you add S plus M plus L equals 180 degrees, right? This is something that we know. Well, if you're still not sure, you can try to guess a number and try to see what happens. That's what's being suggested here. You guess that the smallest angle is 30 degrees. Okay, if it's 30 degrees, then we have if the smallest angle is 30 degrees, the middle angle is going to be what? Check the question and say the middle angle is 30 degrees more than the smallest angle, right? So 30 degrees plus 30 equals 60 degrees, the middle angle. And the largest angle is, according to the question, is 90 degrees more than the measure of the smallest angle. So we have the largest angle as 90 plus 30. This is 120. Well, if we try to add 30 with 60 with 120, this definitely is going to be much more than 180 degrees. That means this guess here is wrong. This is not the right answer. But we're just doing this to understand, to get to know the problem, know what's being given, know what's being asked, and then now maybe we are better prepared to write down equations and find the right answer. That's what we're going to do now. If we say that S is the smallest angle, right? M is the medium angle, and L is the largest. Then we can make a system of linear equations, because S plus M plus L equals 180. We can, by the question, we know that the smallest, not the smallest, but the median angle, the median angle is the smallest plus 30, and we know that the largest angle is S plus 90 degrees. We have a system of 3 equations with 3 variables, and we can also apply substitution method or even elimination method to solve this system of linear equations. I think the best option is going to be substitution method, because we already have M as a function of S and L as a function of S. So we can plug in here on the first equation and solve for S, because we have S plus, and the median angle is S plus 30, and the largest angle is S plus 90, and they all add up to 180. Next step here is to apply, to combine like terms. You have to combine, you can combine S plus S plus S, 3S, plus, and we also can combine 30 and 90 is 120, equals to 180. Finally, we can apply addition property of equality, subtracting 120 from both sides. That means 3S equals, 180 minus 120 is 60. And we can divide both sides by 3, and then we will have S equals 60 divided by 3, 20 degrees. If S is 20, now I can find M, because you remember M is this S plus 30, 50. And you can find also L, because L is 90 plus S, or S plus 90 is 110 degrees. Well, interpret, now we have the results. Interpret the results, check if they are right. Just spend a few seconds to be sure, to make sure that you have the right answer in your hands. One way is to adding up all the angles and check if this is equals to 180, yes. And then we can check the other equations as well, yes and yes. And now states the angles are 20 degrees, 50 degrees, and 110 degrees. This is your conclusion and the solution for this example. And very well, we finished section 4.3. Now we are back to the initial puzzle. What do you think? Can you find an answer to this puzzle? And let me tell you a secret. We can apply some of the knowledge of today's class to solve this puzzle. Think about it. The horse, we can say the number of horses maybe is X, and the number of people Y. One thing you can say about horses is they have 4 feet. So 4 times X, and we can say about people, they have 2 feet. So the total number of feet inside the barn is 32, and the total number of heads is 10. Each one have just one head, X plus Y equals 10. If you solve this system of linear equations here, you can apply elimination method or substitution method, but at the end you're going to find the answer. X equals 6. The number of horses in the barn is going to be equals to 6 horses. This is the answer for our puzzle. Thank you for joining and watching the video, and see you next time.